Hi, Sanjay here, and I'm going to give you a little update on the power density in terms of watts per cc that I can get due to the flux laser principle. This is a invoice I had in my lab and a ferrite sheet which I want to point to. It's only 0.2 millimeters thick. It's meant for RFID or something. It's a Worth electronic sheet with a permeability of barely 100 to 200. I'm going to cut a tiny sliver of it, remove the paper backing basically, and fold it so I'll get 0.4 millimeters, and I'll show you how much power I can get from a little tiny piece which is barely 5 millimeters long when folded, 3 millimeters wide. And so this is the volume, 0.006 cc basically, and I'm attaching two 3-watt LEDs like I did in my last video, and I'm going to show you how much power I get. You'll be a little shocked at the power I can get from this. I have to come a little closer. It's not so much in the air this time, but yeah, I can get a very high amount of power. And let's assume it was not fully bright, only half. And now do the math. Instead of 6 watts, I had 3 watts, and I'm landing up with 500 watts per cc compared to G's 2 watt. That's a factor of 250 times better. And here is the one I had in my previous video, which is actually 12 watts. It's fully lighting up. Here's another one with this tiny ferrite sheet, but a little bigger than the one I just showed you, and it's also capable of lighting a lot. But just to show you the amount of power I can get, look at the distance I can get it over. It's about 1.5 to 2 centimeters easily, and that's a tower of LEDs, which is basically 15 watts at least. And this is in the shared receiver mode, so I can put multiple phones. So here it's 2 of them, 30 watts, very much in the air actually. Yes, and I can even rotate it. There's no problem. Full power and a lot of alignment insensitivity because we are the ones who track the changing resonant peak as you move. And so finally, to recap, we are not twice better. We are not 5 times better, we are not 20 times better, not 50 times better, not even 100 times better, but 250 times better than G.